Okay, so given f of x is equal to 2x minus 1 and g of x is equal to x squared minus 1, we're going to find some combinations of functions. We're going to add the functions, subtract them, divide them, use the compositions, and then we're going to actually evaluate some of these functions at certain values. We also need to find the domains of these functions. So first, we want to find the domain of each of the functions as they exist currently. So the domain of f of x, I don't see any denominators that would make me divide by 0. I don't see any square roots. So the domain of this one is negative infinity to infinity. Similarly, the domain of g of x, I'm pretty confident, is also negative infinity to infinity. If you graph this, you'll also see the domains of these functions are negative infinity to infinity. So when it asks us to evaluate f plus g of x, what we're going to do is we're going to take the function f of x, and then we're going to add the function g of x, just like it says. So f of x is 2x minus 1, and g of x is x squared minus 1. And then I can see I don't really need these parentheses anymore, so we can actually just combine the like terms that are in here. So this is going to be x squared plus 2x, and then negative 1 minus 1 is negative 2. And we know that this is a polynomial, this is a quadratic, it's a parabola, so the domain of that is negative infinity to infinity. Now be really careful. This is where I see common errors, is it's telling us to do the g of x minus the f of x. So I'm going to take the g of x, we're going to write it out, and then we're going to subtract the f of x. And you're going to understand why I put parentheses up here in the first one, even though we didn't really need them. I really encourage you to write the parentheses, because when I take the g of x, it's going to be x squared minus 1, and then we're going to subtract the f of x, which is 2x minus 1. And what's going to happen here is I have to distribute the negative. If you don't have those parentheses there, chances are you are not going to remember to distribute the negative in there. So it's going to be minus 2x and then a positive 1. So our final for the g of x minus the f of x is going to be x squared minus 2x. And then you can see these ones cancel out. And then again, the domain of this one is also going to be negative infinity to infinity because it is a quadratic. All right, this next one is asking us to take the f of x and divide it by the g of x. So we're going to take the f of x and then we're going to divide by the g of x. So the f of x is the function on top, which is 2x minus 1. And then the g of x is the quadratic x squared minus 1. Now we can see that the domain of this one is not going to be all real numbers because we have a rational expression here. X squared minus 1, we need to figure out what values make the denominator 0. Remember that we can factor x squared minus 1 as a difference of squares. So this factors into x plus 1 and x minus 1. So these are going to be the numbers I need to leave out of the domain. So the domain is going to be, again, I've got to leave out negative 1 and positive 1. I can have anything else. So it's going to be negative infinity to negative 1 union or comma negative 1 to 1 and then union or comma 1 to infinity. So when you are dividing fractions, you have to be careful and take a look at the denominator and see what is going to make you divide by 0. All right, f of g of x. So what I'm going to do here is we are going to take the function f of x and we are going to put the g of x inside of it. So what is the function g of x? G of x is x squared minus 1. So we are going to take the function f of x, and wherever we see an x, we're going to put x squared minus 1 in there. So I look at my function f. Here's a good way to do this. I'm going to take my function f. I'm going to actually use red for this, so I'll redo this. So this is going to be the f of x squared minus 1. I'm going to rewrite where I see the x, I'm going to put a set of parentheses. So this is the f of x, right? And then we are going to be putting that function g inside. So we're going to put an x squared minus 1 in here. Now we're going to distribute, so this gives us 2x squared minus 2, and then we have the minus 1 on the outside. So this will end up being 2x squared minus 3. This is the f of g of x. And the domain of that one is, in fact, negative infinity to infinity, because I don't see any fractions or square roots. I'm going to make a line here. I'm running out of space. So g of f of x, now I'm going to take the f of x, and then I'm going to plug it inside the g of x. So what is the f of x? We're going to take g of x, and we're going to plug 2x minus 1 in there wherever we see an x. Well, g of x is x squared minus 1, so I'm going to put a parentheses where I see the x. And then this function is going to go inside, so it's going to be 2x minus 1. Now, 2x minus 1 squared, I'm going to need to FOIL this out. 2x minus 1 times 2x minus 1. And then I'm going to have a minus 1 outside. Okay, we're going to open these up, so it's going to be 2x times 2x is 4x squared. 2x times negative 1 minus 2x. Negative 1 times 2x minus 2x. Negative 1 times negative 1 is positive 1, and don't forget we have a minus 1 here. When we combine our like terms, we get 4x squared minus 4x, and then our 1's cancel out. So this is our g of f of x. Notice that's not the same thing that I got when I did the f of g of x. Now the domain of this one is also negative infinity to infinity. All right, so now we're going to actually start plugging in numbers in this. I'm going to go ahead and hit pause. I'm running out of room on my screen, so I'm going to clean this up a little bit. Okay, so I was running out of space. I cleaned this up a little bit. So now where I see the negative 2 in g of f of x, that's where I'm going to put the negative 2. So this is the g of f of x. To evaluate the g of f of negative 2, we're just going to plug negative 2 in here. So it will be, this is going to be 4 times 4, and then negative 4 times negative 2 is a positive 8. 4 times 4 is 16 plus 8 is 24. I don't have a domain of this one because we're evaluating. So this one asks us to evaluate f divided by g of 0. I go up here and take a look. This is the f divided by g. So where I see that, I'm going to plug a 0 in for x. 0 plus 1, and then 0 minus 1. On the top, I'm going to have negative 1. On the bottom, I'm going to have a positive 1 times a negative 1, which is negative 1. So f divided by g of 0 is negative 1. And then this last one is g of 0. I'm going to work this over here because I don't have enough room. I don't have g of x yet, so I need to find the g of x first. Well, what is the g of x? It's x squared minus 1, so it's going to be blank squared minus 1. Then I'm going to plug the function g in there, so g of x is x squared minus 1. And I need to open this up, so this is x squared minus 1 times x squared minus 1, and then I've got this minus 1. X squared times x squared is the x to the 4th. X squared times negative 1 is negative 1x squared. Negative 1 times x squared is negative 1x squared. Negative 1 times negative 1 is positive 1, and then don't forget to bring down your minus 1. When we combine our like terms, we get x to the 4th minus 2x squared, and then our 1's are going to cancel. Now, it asked us, this is the g of x, right? We're asked to evaluate the g of 4. So circle g of 4, we're going to take this, and where we see our x's, we're going to plug a 4 in. So it's going to be 4 to the 4th minus 2 times 4 squared. And then we got to think about this. 4 to the 4th power is 256 minus 2 times 4 squared is 16. 2 times 16 is 32. 256 minus 32 is 224. So the g of 4 is 224.